This is the Capstone Project for Grantham University, student ID number G00078725. This is for the Best Cup Brew Station. So the agenda for today is going to be the project definition, the block diagram, the high-level component selection, the schematic, the breadboard layout, operational summary, lessons learned, followed by the conclusion. So the project definition, there's problem opportunities and objectives. The problem is there's a need for a coffee maker that not only brews a single serving cup of coffee, but keeps it warm after it's brewed as well. This objective needed to be completed within an 8-week time frame, which is the length of time for this semester. Had to be completed by the 7th week. For the executive summary, the Best Cup Brew Station is designed to simplify people's morning ritual and enhance the coffee drinking experience by producing the perfect cup of coffee. It has built-in features to precisely brew coffee and also to keep the brewed coffee at the optimal drinking temperature. With the power switch on in the brew position, the power source sends current to the hot plate. The hot plate temperature is controlled via the high temperature thermostat. Once the heater is on for a while, the water contained in the water repository goes down the tube, runs through the hot plate, and sends water up the other tube into the shower head. Shower head trickles water over the hot water over the coffee grounds, filters through the coffee grounds, and goes into the coffee cup to produce your brewed cup of coffee. After the coffee is brewed, it goes to the warming position. You flip the S1 switch to the low temperature mode, and that low temperature mode keeps the coffee at the optimal drinking temperature until the coffee is consumed. So the Best Cup Brew Station is an 800-watt coffee maker. Here's the block diagram for it. So with the user input, of course, from the AC power source, the switch is, like I said, is switched to the high temperature position, which is just what I talked about previously. Sends current to the hot plate. The hot plate heats up and heats the water, and thus sends water to the shower head and over the coffee grounds. So when the coffee is brewed, this block diagram here shows the low temperature thermostat. Power source sends to the power switch to the low temperature thermostat. It sends current to the hot plate, cycling at a much lower temperature. It's 85 degrees C, which is a perfect drinking temperature for the coffee. All the user has to do is set the coffee cup on the hot plate after as they're drinking it, when they're done taking a sip. High-level component selection. The components selected are done so by the way of evaluating the current voltage, temperature, and dimensional that applies to the design. Each component was selected for its worst-case maximum operating parameter as it applies to the circuit in which it operates. Electrical and mechanical parts were also chosen based on availability. Some of these parts, based on the time frame or just based on unavailability, were chosen. So that was a critical factor. It really was the time frame as far as determining which components needed to be ordered. For the schematic, again, power source goes to the S1 switch in the high temperature position, goes through the high temp thermostat, which is has a thermal fuse. So it's a critical safety factor. If it gets too hot, it pulls too much current, the thermal fuse will get hot and open up. Then the current comes down here to the hot plate and heats the hot plate up. This indicates the power consumption by the unit, by the hot plate. It's going to be 800 to 900 watts. So for the multimeter, this shows the drop across the hot plate, 120 volts. And these are reading no wattage because it's in the off position down here for the low temperature path. For the breadboard layout, again, this was done in multi-sim. It's a virtual breadboard layout to show the power source, the thermal fuses, the switch for the two positions that send current to the high temperature or low temperature thermostats, heating the hot plate. So the operational summary: with the power on switch in the high temperature position, the Best Cup Brew Station brewed the coffee perfectly. It did result in a perfect single cup of coffee in the desired time frame. I think, like I said in the video, it takes about 1.5 minutes. If you look at the YouTube video down below, there's a link. Then you can see the operation. You can see the brew station in operation. So after the coffee was brewed, you'll see that after watching the video that I switched to the low temperature mode to keep the coffee in the ideal drinking temperature, and then until the power was removed and the switch needs to be turned to the off position. So please view that video. It shows the operational demonstration of the Best Cup brew station. Lessons learned. A couple lessons I want to talk about is I felt that getting a preliminary design completed in order to get the parts on order. So that should be done as soon as possible because the lead times need to be established for the parts you're considering. Even in the preliminary design should be considered as soon as possible. Simulate operation in order to iron out any problems in the early stages of the project prior to build and test. So this is a good indication by running simulations to show that there are things maybe that, and even in the preliminary design, that weren't thought of. So as soon as that can be done, that was one thing I noted for sure that should have been done maybe even earlier than I did it already. And just a point about valuable resources. I'm fortunate enough to work at a company where there's a lot of smart engineers, and I would definitely lean on any resources that are available when walking through a design, just to see if instead of reinventing the wheel, to see if there's anybody who has any opinions, or even if you're not reinventing the wheel, there's people who might have good ideas that you may not have thought of, seasoned engineers. So definitely want to lean on them for their knowledge base. So for the conclusion, the final design was successful based on the product requirements. The completed project adhered to cost, schedule, and quality. The finished product will comply to all safety regulations while operating with the convenient user-friendly controls. The Best Cup brew station will produce the best cup of coffee at a desirable cost.